students! Welcome back to our grade 7 math tutorial. In our last video, we learned about points, lines, and planes. And I know that you are already good at illustrating and identifying them, which is good because it will be easier for you to learn about angles. We have here two lines in the same plane. If we observe, the two lines are pointing in exactly the same direction. Let's try to extend these lines and see if they will cross each other. As we observe, the two lines never cross each other. These lines are called parallel lines. Parallel lines are two or can be more lines in the same plane that are at equal distance from each other and will never meet. We have here two coplanar lines. What if we will extend them? Will they meet or cross each other? Let's see. As we can see, the two lines cross each other at this point. This point is called the point of intersection. And these two lines that meet at this point are called intersecting lines. Intersecting lines are two or more lines that meet at only one point. Intersecting lines form angles. Angles are these spaces formed between the rays. This one. How many angles are here? This space here. 2, 3, and 4. There are 4 angles formed. Let's talk about angles now. From our previous slide, we have two intersecting lines. When we cut the intersecting lines at this point, the point of intersection, we formed rays, the two rays. These two rays formed an angle here. Again, an angle is a space formed by these two rays. Then, the point of intersection of the two rays is called the vertex of an angle. An angle is a figure formed by two rays with a common endpoint and which are not in the same line. The two rays are the sides of the angle, and the common endpoint is called the vertex of an angle. So in this figure, we have here the sides. So an angle has two sides, namely ray AB and ray AC. Then, the vertex is point A. How to name an angle. An angle is named using a number, a vertex, and points on each side. We have here in this figure two angles. We have this one, and this one. We can name this as angle 1 here. The symbol for angle, instead of writing the word angle, you can use the symbol 1. Or you can use the vertex and points on each side. So 3 letters B, O, C. B and C here are points on each side of this angle. And O is the vertex. Take note in naming an angle using the 3 letters, the middle must be the vertex. Then the outer letters can be interchanged. BOC or COB. COB or BOC. O, the vertex, must always be at the middle or the center. Now this angle can be named as angle 2 or angle BOA or AOB. It says here that we can name angles by using the vertex alone. But in this case, we cannot name this as angle O. Why? It's because when we say angle O, it would mean this angle 1 or this angle 2. It might be confusing. So, when using a vertex to name an angle, make sure that the angle is just a single angle and not like this one that the two angles are sharing a common vertex. So let's recall measuring angles. Recall, this is a protractor. This is an instrument used in measuring angles, and the unit is degree or degrees. Now, this is the angle that we are going to measure. If you observe here, this side of an angle is aligned with 0. Look at the top scale. 0. You always look at the 0. You align one of the side of an angle to 0. Then the vertex must be at this point. Then, if it's aligned already, you can look at the other side. So since we are using top scale, you have here the 0. You look at the top scale, the number here is 40, and it's between 40 degrees and 50 degrees. It's exactly in the center, so this is 45 degrees. So this angle measures 45 degrees. And this angle here, so here in this figure, it's not the top scale, it's the inner scale. It's being used. Look at the 0 here. So one side must be aligned with 0. Then 0 is in this scale here. Then we'll be looking at this scale. So 0, 10, 20, 30, 40, up to 90 degrees. So this angle measures 90 degrees. So what are the types of angles? So we have here, the angle is greater than or between 0 and 90 degrees. Example, 45 degrees angle. This is what we call an acute angle. If the angle is exactly 90 degrees, that angle is called a right angle. Then if the angle is greater than 90 degrees, it's between 90 degrees and 180 degrees. Example, 140 degrees is an obtuse angle. But if the angle is exactly 180 degrees, it's what we call a straight angle. Then, if the angle is between 180 degrees and 360 degrees, 360 degrees is a complete revolution, a complete circle. Example, 210 degrees. So it's what we call a reflex angle. So another example for this is 190 degrees. As long as it's greater than 180 degrees, so 181 belongs to a reflex angle up to 359 is a reflex angle. Then, complete revolution, or if one of the side of the angle rotate in a complete circle, then the measure of that angle is 360 degrees. It's a revolution. One revolution is 360 degrees. What are perpendicular lines? Two lines that are intersecting and form right angles. So, in this figure, these two lines, line CD and line AB, form a 90 degrees angle. 1, 2, 3, 4. 90 degrees angle. So, this is an example of perpendicular lines. So, we'll say line CD is perpendicular to line AB, or line AB is perpendicular to line CD. The symbol for perpendicular or perpendicularity is this one, the inverted T. So in this figure, by the way, this small square here, the symbol for a 90 degrees angle, just like here. You can see a small square, then that measure is 90 degrees. So since we have here a small square, this means that this angle MNB is a 90 degrees angle. So meaning these two line segments form a right angle, so they are called perpendicular. So we can say that line segment AB is perpendicular to line segment MN, or line segment MN is perpendicular to line segment AB. Take note of the symbol for perpendicularity, inverted T. What are adjacent angles? Two angles are adjacent if they have a common vertex and a common side, but no interior points in common. Like in this figure, angle ABD and angle DBC are adjacent angles. They share a common side, ray BD, and a common vertex point B, but they don't have common interior points. So what are interior points? Interior points, this space here consists of points that is in this angle ABD, and this space here consists of points in or the interior of DBC. They don't have common interior points, so they are adjacent with a common vertex point B. Complementary angles. Two angles are complementary if their sum measures 90 degrees. Each angle is a complement of each other, just like here in this figure. We have here a 30 degrees angle and a 60 degrees angle. They complement each other. When you add them, 30 degrees plus 60 degrees will sum up to 90 degrees. We have also here in this figure, this small square here represents that the angle formed here measures 90 degrees. So, the smaller angles that these 90 degrees or right angle contain, this angle 1 and angle 2, are complementary angles. Supplementary angles. Two angles are supplementary if the sum of their measures is 180 degrees. Let's look at these examples here. We have an angle which measures 130 degrees and the other one measures 50 degrees. Let's add them. 130 degrees plus 50 degrees, the sum is 180 degrees, thus they are supplementary. How about this one? 110 plus 70, the sum is 150 degrees, still supplementary. There are supplementary angles that are non-adjacent, just like here in this picture. They are non-adjacent. They don't share a common vertex and side. There are also some that are linear pair, that are adjacent and supplementary. So what is a linear pair? Two angles which are supplementary and adjacent. So just like this one, when you add these two angles, then will form a straight angle. The sum is 180 degrees. So you have angle ABD measures 40 degrees, and angle CBD measures 140 degrees. When you add 140 degrees and 40 degrees, the sum is 180 degrees. They are called a linear pair. Now let's have vertical angles. Pair of angles formed by two intersecting lines. Vertical angles are always congruent. Here in the figure, it's colored red. The space colored red here are pair of vertical angles, the angle ABD and angle ABC. The other pair is the white one. ABE and DBC are pair of vertical angles. Take note always that vertical angles are always congruent. What is congruent? Congruent, they have the same measure. So if this one is 46 degrees, then its pair is also 46 degrees. Then the other one is 134 degrees. And its pair is 134 degrees. These two pairs are what we call vertical angles. If you observe here, it forms a circle. When you add 46 degrees plus 134 degrees plus 46 degrees and 134 degrees, you add up 4, then the sum of these four angles is 360 degrees. Since one circle, one revolution is or measures 360 degrees. So again, congruent angles are angles that have the same measurement. Examples, angle G and angle S, they have the same measurement, 42 degrees. Angle R and angle Q, they have the same measure, 155 degrees. And these two angles, 110 degrees, they are called congruent angles. Now, we are going to answer some exercises. Are you ready?
In this part, we are going to solve for x. where x here represents the measurement of an angle. To answer number 1, let us examine first as to what type of angle pairs are the given and the unknown x. Are they complementary angles, supplementary angles, linear pair, or vertical angles? I heard someone saying vertical angles. Yes, you're right. And remember that vertical angles are always congruent. When you say congruent angles, they have equal measurement. This symbol means that this angle here has equal measure with this angle. So therefore, if this is 70 degrees, this one also measures 70 degrees. So therefore, the value of x here is also 70 degrees. Number 2. What type of angle pairs is shown in the figure? Yes, you're right. They are linear pair. And what are linear pairs? Two angles that are always adjacent and supplementary. And what are supplementary? Two angles whose sum is 180 degrees. So, if their sum is 180 degrees, so we will say x plus 130 degrees is equal to 180 degrees. So, we have the equation x plus 130 degrees equals 180 degrees. To solve for x, we will combine all the numbers here in this side of the equation, leaving x here alone in this side. So to make that, we will apply the subtraction property of equality. X plus, you copy, x plus 130 degrees subtracted by, copy 180 degrees, minus, subtracted by blank. So what number that we will subtract, making this equal to 0 to make here in this side alone? Correct, 130 degrees. 130 degrees minus 130 degrees equals 0. So, what will remain here in this side of the equation is x. Now, to make the equation still balance, we will also subtract 130 degrees in the other side of the equation. So, simplify 180 degrees minus 130 degrees. The answer is 50 degrees. So, therefore, the value of x is 50 degrees. Or in short, we know that it is 130 degrees. So, what will be the value of x here, making it 180 degrees? We'll just subtract 130 from 180 degrees, and that is 50 degrees. To check, we will add them. This is 50 degrees. So 130 degrees plus 50 degrees is it equal to 180? Yes, equals 180 degrees. Number 3. As we can see in the figure, there is a small square. To recall, this small square means that this angle is a right angle, or an angle whose measure is 90 degrees. This right angle here contains two small angles, or two smaller angles, in which one of them measures 65 degrees and the other one is unknown. So we can say that these two smaller angles are complementary angles. Since these two smaller angles are complementary, and thus their sum is 90 degrees, we can write the equation as x plus 65 degrees is equal to 90 degrees. So we will solve for x in this equation. Just like in number 2, we will apply the subtraction property of equality. our goal here will be to make this x alone in this side of the equation, and the numbers will be combined in the other side of the equation, and the right side. So, applying the subtraction property of equality, we will copy x plus 65 degrees, subtract it or minus blank 90 degrees, copy minus blank. What number that when we subtract it from 65 degrees will make this 0? Same number, which is 65 degrees. To make the equation still balanced, we'll also subtract same number here. So that 65 minus 65 degrees equals 0, leaving x here on the left side of the equation, and simplify this. 90 minus 65 degrees, the answer is 25 degrees. So the answer is 25 degrees. The value of x here for the measure of this smaller angle is 25 degrees. To check, we will add 65 and 25 degrees. So 65 degrees plus 25 degrees, is it equal to 90 degrees? Yes, the answer is 90 degrees. Or in short, to find this angle here given the complement, which is 65 degrees, we can just subtract the given angle from 90 degrees. So 90 degrees minus 65 degrees. The answer is 25 degrees. So that's it. Number 4. What is the measure of angle 1 if its supplement measures 90 degrees, 19 minutes, 36 seconds? Take note that what is asked here is the measure of angle 1 given that its supplement measures 90 degrees, 19 minutes, and 36 seconds. So this is angle 1. So this angle here is its supplement, which measures 90 degrees, 19 minutes, and 36 seconds. Are you familiar with this symbol? This symbol is for minute, and this symbol is for seconds. Don't be afraid if you are new to this or not familiar with this one, because we can just relate this to the unit of time. Degree is to hour, minutes is to minutes, seconds is to seconds. Are you still confused? Well, we can write it this way. 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. See, it's just similar to time. 1 hour is to 60 minutes, 1 minute is to 60 seconds. Going back to the question, we are going to find the measure of angle 1 given this one. So we already encountered finding the supplement of an angle, am I right? So to find the supplement or to find angle 1, we will just take the shorter way by subtracting the given angle from 180 degrees, since they are supplementary. So we have here 180 degrees minus the given 90 degrees, 19 minutes, and 36 seconds. We need values for here. So we will borrow 1 degree from 180, making this 179 degrees. So we know that 1 degree is equal to 60 minutes. So we'll write here 60 minutes. We still need seconds here, the value for seconds. So just like what we did here, we will borrow 1 minute from here, making this 59 minutes. And we know that 1 minute is equal to 60 seconds. So we'll write 60 seconds. Now we are ready to subtract. 60 degrees minus 36 seconds is, here 10, 5. So 10 minus 6 is 4. 5 minus 3 is 2. So we have 24 seconds. So 59 minus 19 is 40 minutes. And 179 minus 90 degrees is 89. So 9 minus 0 is 9. 70 minus 9 is 8. So the measure of angle 1, we have here small letter m, stands for the measure symbol angle 1 is equal to here 89 degrees, 40 minutes, and 24 seconds. So that's it. Number 5. The measure of the angle is 8 less than the measure of its complement. Find the measure of the angle and its complement. What is asked here is the measure of the angle and its complement. Given that the measure of the angle is 8 less than, so we'll take note on the given condition that the measure of the angle is 8 less than the measure of its complement. So we will represent each unknown here. We can also draw an illustration to understand better. So let's draw an illustration here. So complement, the term complement meaning the sum of the two angles is 90 degrees. So we'll just draw here. A right angle. This small square means 90 degrees angle. So let's say we'll represent the angle by x. So if this is the angle, this is x. So therefore its complement is 90 minus x. 90 degrees minus x. Okay, so with this we can write an equation. So the equation will be, so this is by the way representation. So we'll just write left x be the measure therefore 90 minus x is the complement of the angle. So we'll write the equation so that we can solve for the value of the x. And to make the equation, we'll base equation in this statement. Let's analyze the given statement. The measure of the angle, this x, is 8 less than, so it's less than 8 as compared to its complement. So this is lesser than 8. So we can write it this way. X equals this equation. To make them equal, we will write 90 minus x. We will subtract 8 here. Since this angle here is less than 8, it is complement. So to make them equal, we will subtract 8 here. For the other way around, we can also write as x. We will add 8 here for the x so that we will become equal with its complement. The complement is 90 minus x. Now we can solve for the value of x. We can either use this equation or this equation. We'll use this equation. Okay, so this is the equation that we have chosen. So we'll solve for x. First thing we do is to get rid of the x here. making x at the left side alone and the numbers, all the numbers at the right side of the equation. So how to get rid of this negative x here? Just like in the other numbers, we will apply, this time since this is negative, we will apply the addition property of equality. So we'll copy x plus blank, then we'll copy 90 minus x plus a number or variable that we will add so that negative x here plus this one will become 0, and copy 8. So what will be added here, making this negative x equals to 0? So we'll add x, so that negative x plus x is, the sum is 0, leaving 90 and negative paper minus 8. Then, since we added x here on the right side, we'll also add x at the left side of the equation. So x plus x equals 1x plus 1x is 2x. Now we'll simplify this one. So 90 minus 8 is equal to 82. Then copy here 2x. We still have here the coefficient 2. So we'll make this 1. To make this 1, we will divide both sides by 2. We applied division property of equality. So 2 divided by 2, the answer is this one, x. Since 1 times x is x, and 82 divided by 2 is 41. So the value or the measure of the angle is 41 degrees. So this is 41 degrees. So since the measure of this angle is 41 degrees, so if you're going to substitute 41 to this expression, you have 90 degrees minus 41 degrees. The answer is 49 degrees. So therefore, this angle here measures 49 degrees. So if you're going to check 49 plus 41 is equal to 90 degrees. And if we will check the statement here, that the angle represented by x is 8 less than the measure of its complement. So this angle here, which is 41 degrees, is 8 less than this angle here, which is 49, which is true.